Alright guys, today we're going to learn how to simplify radicals. So radicals are the same thing as square roots, and we always start simplifying radicals by creating a factor tree. So we're going to start with 150, because that's my number up here, and I want to get all my factors of 150. So in order to do that, you need to divide. The numbers that are like special numbers that you can always divide by, for most of the numbers, will be 2, 3, and 5. So 2 if it's even, 5 if it ends in a 0 or a 5, and then 3 if it's kind of like a weird number. So those are what I would try first. Now we don't want any decimals, we want to get all whole numbers, okay? So 150, so we're going to take 150 and we're going to divide that by 2 because it's even. So 2 and 75. Then we can't divide 2 anymore, so we're going to take 75. Since it ends in a 5, we're going to divide by 5. So we have 5 and 15, and 15 divided by 3 is 5. Okay, so this is our factor tree, and we have these guys here. Now these are our branches. So we end with 2, 5, 3, and 5. So that means if I multiply 2 times 5 times 3 times 5, I will get 150, and I'll show you. So 2 times 5 times 3 times 5 gives me 150. So these are the factors that make up 150, and they're my smallest factors. Now, since you don't see a number on this shelf, there's an automatic 2 sitting up here. So that's really important. You have to be careful and know which number is sitting on your shelf. So what that means is I'm looking for a pair of the same exact number. Well, 2 doesn't have a partner and 3 doesn't have a partner, but 5 and 5 each have a partner. Okay, so I have 2 5s and I'm looking for a pair of them. So now what you're going to do is if you have a pair, one of the pairs goes out of the radical and then the other goes away. So we right now have in our square root or underneath our radical, we have 2 times 3 times 5 times 5 because that makes 150. But here I have a pair of 5s. So one of the 5s escapes and goes out of the radical and the other one fades away. Okay? Now, I don't have a pair of 2 and I don't have a pair with 3. So they just hang out underneath the radical. And then we simplify. So 5, and this is actually getting multiplied by our radical. On the shelf, I still have a 2. So it's not a 5 on the shelf. He sits out in front, and he's actually getting multiplied. So it's 5 square root of 2 times 3 is 6. Now, sometimes your calculator will not reduce for you, and you need to understand how to reduce for other problems. But you can see if your calculator will reduce it and double check your answers. So the square root of 150 is 5 root 6. So this is our reduced radical and we got that as well. So let's do another one. So 27, so we start by making a factored tree. Now 27 isn't even, so we can't divide it by 2. And it doesn't end in a 0 of 5. So we're going to try dividing 27 by 3. So 27 divided by 3 is 9. So 3 makes 9, and 9 divides by 3 and 3 as well. So the ending of my tree, the branches, I've got 3, 3, and 3. For this guy, on my shelf, I have a 2. So I'm looking for a pair of 3s. So let's do these guys. So again, I can rewrite the square root of 27 is the same as 3 times 3 times 3. We're taking a pair of 3s. One of the 3s goes in front and the other goes away. So I have 3 square root of, the thing that I have left is a 3. That's my extra branch. And again, we can double check. So the square root of 27 reduces to be 3 root 3. Okay, let's go to number 4. Number 4, you do not have to divide by 2 if you do not want to. So 384, let's divide by 6 instead. Let's see if that works. 384 divided by 6. Oh, yeah, it does. So 6 and 64. 6 divides off to be 2 and 3. So these are our end branches for this guy because I can't divide those any lower. 64 divides off to be 8 and 8, which can also get smaller. So then I can have 2 and 4, and again 2 and 4. Now, my 2 cannot go any smaller, so those are done. Notice that I'm kind of circling them on my way. So that's why I don't forget about anybody. 4 branches off to 2 and 2, which cannot get any smaller. And 4 also branches off to 2 and 2. And these guys are done as well. Now, this time I'm looking for 3, not just a pair, because I have a 3 on my shelf. So let's see. I'm going to rewrite. I have that 1, 3. We'll put him in front. Then I have 1, 2, 3, 4, 5, 6, 7 2s. 1, 2, 3, 4, 5, 6, 7 2s. And he is a cube root, so we keep that 3 on the shelf. Okay, so now we're looking for 3 of them. So that means I have 1, 2, 3. So 1 pair of 3s. So one triplet of 2s. That 1 2 is going to go out in front. Here, we'll put this little guy here. And then the other 2 fade away. Then I have another triplet of 2s. 1, 2, 3. So 1 more of these 2s has to go out in front. And again, they're getting multiplied. And the other 2 fade away. So now what do I have left? I have this 3 and this 2. And again, you could have seen the same thing here. I've got 3 2s. 1 goes out, the other 2 go away. I have 3 more 2s. 1 goes out, the other 2 go away. And what I have left underneath my radical are 2 and a 3. So now we're going to simplify. So we multiply our 2 times 2 to get 4, keep our 3 on our shelf, and 2 times 3 is 6. Okay, let's check our answer. So we have a cube root this time, so we have to type 3 first. Second, X with the boxy button to make that 3 sit on its shelf. So that's this guy right there. And then we type 384. Well, we got an answer of 7.2. So now we're going to type in what we got. So this is 4 times the cube root of 6. And we got 7.2. Perfect match. So we are doing this correctly. Notice that the first time when I just typed this in, it didn't reduce my radical for me. So you have to know how to do it because some of them will not be reduced with your calculator. So if you have more questions, let your teacher know. When you're looking for pairs or triplets today, you need to make your factor tree. And yeah, have a great time. If you have any questions, talk to your teacher.